Good evening. Today we're going to look at transformations of quadratic functions. And when we talk about transformations, if you remember from 7th grade, you did a little geometry there and you talked about transformations. And if you remember, transformations are just the movement of a figure on a coordinate plane. Sometimes they move right, sometimes they move left, sometimes they move up, sometimes they move down, and sometimes we even have a reflection. In other words, if I were to turn this over and make it face down, that would be a reflection of this quadratic, and it would be reflected over the x-axis. And sometimes we have a reflection over the y-axis. So those are the transformations that we're going to look at in this particular unit. And what I've done here is I've drawn the parent function y equals x squared. And the reason why I drew that is because every transformation that you will do will always be based on y equals x squared, which is called the parent function. And every function that you create as a result of a translation will be like a child. Okay, so this is the parent and all the movements are the children. All right, so with that said, I'm going to keep this up here and we'll refer to it, and I'll talk through these as we go. So our number one says, find g of x, where g of x is a translation 1 unit up of f of x, which equals x squared. So they're telling us again the parent function is f of x, or y as I have it here, is equal to x squared. And it says write your answer in the form of A, which is the how skinny or how fat it is. We're not going to do much with that right now. It's coming though. And then inside the parentheses is how does the function move left or right? And then this K is how does the function move up or down? So let me write that so that you know what we're looking at. A is how fat or how skinny. X, and they're using H, so I'll use that as well, is a left or right movement, plus K is an up or down movement. So what we have is f of x is equal to x squared, and it said that we had a translation 1 unit up. So there was no movement left or right, so we don't need the parentheses. What there was a movement of the quadratic 1 unit up. So I'm just going to do the K part here. So this would be x squared plus 1. So when you put it in, you're going to put your x, type in your exponent, and then plus 1. All right, let's look at 2. It says find, so this actually, let me go back to number 1. This ended up being g of x. It's the name of the new function. So now, going back to number 2, we said find g of x, where g of x is a translation 4 units right of f of x equals x squared. So our original function is f of x equals x squared. And then it says find g of x. And what does it tell us? It says that there's movement left or right. So we know we need some parentheses. And what we're doing is we're saying inside of that parentheses, I took my function and it says 4 units right. So when you think right, or when you see right, what I need you to do is think opposite. So if I say, oh, it's over here on the right hand side, like say if I just move this 4 to the right, what I'm writing inside the parentheses is what does this function have to do to make it back to 0? Well, it would have to move 4 to the left. And I'm moving the entire function. So when we put our transformation inside the parentheses, we're moving on the x-axis. Okay, we're moving just right and left. If it says right, then I write the opposite sign, which is negative. If it says move left, then I write the opposite sign, which is positive. So our g of x function is equal to x minus 4 squared, because I'm moving again on the x-axis. So I would just put in here x minus 4 and then squared. Ooh, almost got that one wrong. Squared. There we go. Number 3, it says find find g of x, where g of x is a reflection across the x-axis of f of x equals x squared. So here, if I were to take my parent function, which is x squared, and fold it down, if you'll remember, when a quadratic faces up, then my a is positive. But when it faces down, like this, my a is negative. And what is a here? A is that imaginary 1. So I'm going to do g of x is equal to negative x squared, because I simply just reflected it or flipped it over. Number 4, find g of x, where g of x is a translation 6 units left and 2 units up of f of x equals x squared. So we have f of x is equal to x squared. It's our parent function. And what it's saying is, okay, it moves 6 units to the left. So if it's moving 6 units to the left, it's over here. What does it have to do to get back to 0? It has to move 6 units right. So I came from over here back to 0. That's why I'm writing a plus sign instead of a minus sign, even though it says left here. And then it says it moved 2 units up. So this is my plus or minus. This k is my movement up or left, up or down. So I would put plus 2. So I would type x plus 6, and that's squared because we're talking about a quadratic. And then I would type in how much it moved up or down. Number 5, we've got find g of x, where g of x is a translation 4 units left and 9 units up of f of x equals x squared. So we've got g of x equals, well, we know there's movement within the parentheses, and it was 4 units left. So we're going to write plus 4, because remember we write the opposite. And it was 9 units up, so that would be plus 9. Now, if you notice, anything that's up or down, we write exactly what it says. So going up is plus, going down is minus. It's only opposite, and I'll put that note here, opposite inside the parentheses. So we have x plus 4. Don't forget your exponent of 2 to notate that this is a quadratic function, plus 9. All right. Now, we'll move over here and do number 6. We've got f of x, and we know that's going to equal x squared. We know that because it's here. And then we're trying to find the new function g of x, where g of x is translated 6 units left. So since there's movement on the x-axis, I need my parentheses. I'm going to write the opposite of what I see. So plus 6, and it's the parent function, and then it moved 3 units down. Next, number 7, we have f of x is equal to x squared. And this time we have g of x, which again, it's sliding left and right. So we're going to have our parentheses. We're going to put our squared there. So we've got x, and it says the translation was 7 units left. So we're going to put plus 7, because we write the opposite side. And then it was 2 units down. So minus 2. All right, let's move on to the next one. We've got, again, f of x is equal to x squared. And g of x, our new function, is a translation 4 units right. So because we're moving right or left, we know we need our parentheses. It says it's moving right, so we're going to write the opposite sign, which is to subtract 4. And then we're moving 3 units up. So we're going to put our plus 3 on the outside of the parentheses. All right, this time they're giving us a graph and asking us to write the function rule. So when you're looking at the graph, we're going now, instead of being given words and writing our equation, we're going to write the equation from this picture form. Now, it says the graph of g of x. Okay, so this was the result of a transformation from our parent function x squared, which went through the origin. And they're asking us to write the rule. So what we know is that this function did not move left or right. So all I need is the parent function first. Okay, but what did it move? It moved 8 units up. So the parent function just moved 8 units up, but did not move left or right. Now here we have g of x. So it's been transformed, and it was a translation of our original function, which is x squared. So we're going to write the function rule for this. Since it did not move, the quadratic did not move left or right, all we need to do is type in x squared. And then we say, okay, how much did it move up? Well, it moved up 1, 2, 3. So we just put plus 3. Now, oh, finally a left or right movement. So we've got the transformed function, and it's a transformation of x squared. So this time, because we do have a left or right movement, we need our parentheses. And we're going to say, okay, x, now it moved right. So think, what does it have to do to get back here to its parent? Just think of this quadratic. It wants to move home. Moved out, let's move home. Well, they went 7 blocks away. So to get home, they'd have to go 7 blocks back, which is minus 7. And then we're going to put our squared out here. Now it didn't move up or down, so we don't need to say anything about a plus or a minus out here, where k is our movement up or down. All right, let's look at this one. Again, we've got our parent function, and it's just a downward movement. So we've got x squared, and how many did it move down? It moved down 10. Now, oh my goodness, they've given us one where there's 2 of them. It moved left and right, and it moved up. So on this one, what I want you to look at is, okay, we had a movement to the right. So x moved, or the quadratic moved, 3 positions or 3 units to the right. So how many units would they have to move back to get to 0? Well, they'd have to move 3. So we're going to say minus 3, and we're talking about our quadratic, so we're going to put our squared out here. Now, how many units did they move up? They moved up 4, so we would be plus 4. Now, I do want to say this to you, guys, transformations of a quadratic, if you can get this down, you can transform any function. The way you do it for any function is the same. I'm going to do one more for you, and then I'm going to let you go for the night. So, we've got a movement left or right, and a movement up or down. So I'm going to put in my parentheses to show that the quadratic moved 7 to the right. So to get back to 0, I would have to subtract 7. And then the quadratic moved up 6, so I just put plus 6. All right, so I tell you what, why don't you go ahead and get that 100? Talk to you later.